Greetings, this is Rishik Ganta of registration number 19BCE1494, recording this video for the digital assignment 2 of blockchain and cryptocurrency CSE1006. The topic that I got for this is SHA-512. Hash functions. Hash functions condense arbitrary size messages to a fixed size. They do so by processing message in blocks, some through some compression function, either custom or they are either custom or block cipher based. It takes a hash function takes a variable length block of data m as input and produces a fixed size hash value where h, the hash, is equal to the hash function of n. Hash function diagram. This is a message. This is when it is given to the hash function, it generates a hash value, which is also called as a message digest. Here you can see where m is the input message of any arbitrary length, h is the hash function, h is a fixed length output, and capital H is the hash function. Uses of hash function, it is used in message authentication and confidentiality. The message and the initial hash are passed, then we get a digest, and then it is given to this is this is a receiver. The receiver receives the message, then it is passed to descriptor, I mean a decryptor, and a decryptor again generates a message and the hash, and it is compared for tampering. This is like how authentication is done. Hash functions, the properties of a good hash function. The properties of a good hash function are the output produced is 2D, random in nature, and evenly distributed. Any change to any bit or bits in the message should result into big change in the hash code. Cryptographic hash function. It is an algorithm for which it is computationally infeasible to find a data object that maps to a predefined hash result, that is one-way property. Two data objects that maps to the same hash result, that is collision-free property. Because of these characteristics, hash functions are often used to determine whether or not data has been changed or altered. Properties of hash function. Crypto hash function h of x must provide compression. Output length is small. Efficiency, that is h of x is easy to compute for any x. One way, that is given the value of y, it is infeasible to find an x such that h of x equal to y. It should have high collision resistance, that is it is infeasible to find any x and y such that with x not equal to y such that h of x equal to h of y. Many collisions exist, but we cannot find any. Iterated hash function. All cryptographic hash functions need to create a fixed size digest out of a variable size message. Creating such a function is best accomplished using iterations. Instead of using variable size input, a function with a fixed size input is created and is used as a necessary number of times. This fixed size input is referred to as the compression function. It compresses an n-bit string to create an m-bit string where n is greater than n. This scheme is iterated cryptographic hash function. Two groups of compression functions. There are two approaches. Compression function is made from scratch, and other is hash functions based on block ciphers. The first approach is message digest, and the second approach is secure hash algorithm. Secure hash algorithm. The secure hash algorithm is a family of cryptographic hash functions published by the National Institute of Standards and Technology (NIST) as a U.S. Federal Information Processing Standard (FIPS). It is sometimes referred to as Secure Hash Standard (SHS). SHA-0 or SHA-0. It is published in 1993. It is a 160-bit hash function. It was withdrawn shortly after publication due to an undisclosed significant flaw and replaced by a slightly revised version of SHA-1. SHA-1, it is published in 1995. It is a 160-bit hash function based on message digest 5 or MD5 algorithm. It is designed by the NSA, that is National Security Agency of USA, to be a part of the digital signature algorithm. Its cryptographic weaknesses were discovered in uh, SHA-1, and the standard was no longer approved for most cryptographic uses since like after 2010. SHA-2, it was published in 2001. It was wholly accepted by cryptographers in the year 2011. It is a family of two similar hash functions with different block sizes known as SHA-256 and SHA-512. They differ in the word size. SHA-256 uses 32-bit words, whereas SHA-512 uses 64-bit words. Secure hash algorithm, SHA. SHA is originally designed by NSIT and NSA in 1993. It was revised again. This is just a recap. It was revised in 1995 as SHA-1. It is used as the USA standard for DSC signature scheme. It is based on the design of MD5 with key differences. It produces 160-bit hash values. The recent results of 2005 results of SHA-1 have raised concerns on its use in future applications. Revised Secure Hash Standard, NIST issued revision FIPS 8 and 2 in 2001. It adds 3 additional versions of SHA, that is SHA-256, SHA-384, SHA-512, designed for compatibility with the increased security provided by the AES cipher. The structure and detail is similar to SHA-1, hence analysis should be similar, but security levels are rather higher when compared to SHA-1. SHA-1 is based on the Merkle-Damgard scheme. Merkle-Damgard scheme, in the Merkle-Damgard scheme, there is a compression function. Initially, it is the original message is with a padding is divided into m t bits, which is like each bit is of n, like each block is it, or each message is of n bits. The first message is passed and compression and hash value h0 hash value is passed, which when these both are passed to the compression function, and output of h1 hash is given. This hash is again further passed with the message m2 this to the compression function. This process is repeated until t time such that h of t minus 1 and m of t gives the h of t hash, the h of t message digest. The final message, like the final hash, is called the message digest, which is of m bits length. This is the algorithm. The scheme uses the following steps. The message length m and padding are appended to the message to create an augmented message that can be evenly divided into blocks of n bits, where n is the size of the block to be processed by the compression function. The message is then considered as t blocks, each of n bits, which we call each block m1, m2, so on until mt, and we call the digest created at t iterations, that is h1, h2, so on until ht. Before the starting iteration, the digest h0 is set to a fixed value, normally called iv or initial vector, like the initial value of the initial vector. The compression function at each iteration operates on h of I minus 1, that is the previous hash or the previous message digest, and the new message mi, to create a new message digest or hash as h of I. In other words, we have h of I is equal to a function of h of I minus 1 and m of I, where f is the compression function. H of t is a cryptographic hash function of the original message, that is h of m. If the compression function in the Merkle-Damgard scheme is collision resistant, the hash function is also collision resistant. Secure hash algorithm SHA-512, the message size is less than 2 to the power 2 to the power 128 and the message digest size is 512. The block size is 1024. These are in bits, 512 bits and 1024 bits. So a message of n into 124 bits is given, which is further divided into n 1024 bits of m1, m2, so on until mm. Each is given to the hash function, and again word addition is done and a message is generated and so on. If you see here, this is the message digest generation using SHA-512. So the initial message of L bits is again divided into n bits of each 1024 bits length, and again an initial IV vector is passed. IV vector is passed to the, this is the again the compression function, and word by word addition of mod 2 power 64 is done, and again the process which is repeated before is done. The process of SHA-12 consists of the following steps: append padded bits, append length, initialize hash buffer, process the message in 1024 bit blocks, which forms the heart of the algorithm, output the final state value as the resulting hash. Padding bits to be appended in step 1. The message is padded so that its length is congruent to 896 modulo 1024, that is the length. This padding is always added even if the message is in desired length already. Thus, the number of padding bits is in the range of 1 to 1024. It consists of a single one followed by the necessary number of zeros. This is called, like, the padding is consists of a single one followed by a necessary number of zeros. The appending length in step 2. Here we add 128 bits consisting of the length of the original message. The length of the message is taken in a hexadecimal format for adding this in 128 bit pad. Thus, the length of the block becomes 1024, that is 896 plus 10, like 896 plus 128. Length field and padding. Length field in padding is given by the equation mod m plus mod p plus 128 equal to 0 mod 1024, which gives rise to p is p mod p, which is the padding, equal to minus mod m minus 128 mod 102. The format of padding is 1 followed by necessary number of zeros, as I mentioned earlier. Initializing the hash buffer. A 512-bit buffer is used to hold the intermediate and final results of the hash function. The buffer can be represented as 8 64-bit registers, which are which can be named A, B, C, D, E, F, G, H. These registers are initialized to the following 64-bit integers. For A, it is 6A09E667F3BCC908, and like for the others, you can see what is the corresponding 64-bit integer is. These values are stored in big endian format, which is the most significant byte of a word in the low address, leftmost byte position. These words were obtained by taking the first 64 bits of the fractional parts of the square roots of the first 8 prime numbers. SHA-512 compression function. This is the heart of the algorithm. The processing message in 1024 bit blocks consists of 80 rounds, which is in which updating a 512 bit buffer is divided into 8 blocks based on fractional part of square root of the first 8 prime numbers, using a 64-bit value weight derived from the current message block and a round constant based on cube root of the first 80 prime numbers. So this is the flow diagram. Like the first message schedule, the first word is sent, and these are the initial, like this is the uh, 64-bit register that mentioned here. So this is 64-bit register. After round 1, the weight is sent and it is again up. The register is updated, and again after round, like for round T, and after round 80, again the weight is sent and the register is updated, and then the end padding is added and the hash function is obtained. Step 5, after all the N1024 bit blocks have been processed, the output from the N stage is a 512-bit message digest. Here we can summarize the behavior of SHA-512 as follows: H0, which is the initial vector or IV; HI, which is the sum 64, that is HI minus 1 ABCDF. This is the values. This is the 64-bit register. Message digest MD, which is hash function after the n iteration, where IV, the initial value of ABCDEFGH buffer, which is defined in step 3. ABCDEFGH I, the output of the last round of the processing of ith message block. N, the number of blocks in the message. Sum 64 addition modulo 2 power 64 performed separately on each word of the pair of inputs. MD, the final message digest value. SHA-512 round function. In this, like for the function, these are the registers, 8 register bits of 64, like 64 length. So in the first, the elements are CH, which is CH of EFGH, which is E and and of E and F, which is XORed with not of E and G, and MAG of ABC, which is again uh, B and A XORed with C and A XORed with C and V. Summation A, which is ROTR of A comma 28 XORed with ROTR of A comma 34 XORed with ROTR of A comma 39, and again summation of E, which is ROTR of E comma 14 XORed with ROTR of E comma 18 XORed with ROTR of E comma 41. Plus is the addition modulo 2 power 64, and again KT is a 64-bit additive constant, and WT is a 64-bit derived from the current 512-bit input block. Calculation of W. WT is used in each of the 80 rounds of each block, where T ranges from 0 to 79. Each weight is of each WT is of length 64 bits. WT is calculated as follows: the first 16 weights is 0 to 15 and are taken as it is from the message. That is 6 into 64, that is 1024. The rest of the weights are calculated using the formula WT equal to dou 1 of x into WT minus 2 with added with WT minus 7, W of T minus 7 added with dou of 0 of x into W of T minus 15 plus W of T minus 16, where dou 0 of x is again ROTR of x comma 1 XORed with ROTR of x comma 8 XORed with SHR of x comma 7. Dou of 1 is ROTR of x comma 19 XORed with ROTR of x comma 61 XORed with SHR of x comma 6. The structure of each of the 80 rounds is shown. Each 64-bit word is shuffled along one place and in some cases manipulated using a series of simple logical functions, and not, or, XOR, rotates, that is ROTR, in order to provide the avalanche and completeness properties of the hash function. Initializing the hash value, the first 7, like the 0 to 8, these are the initial values of the 8 registers, first 64 bits of the fractional parts of square roots of the first 8 primes. So this is the hash values which I've mentioned before, and these are the k weights applications of SHA. These are the k weights. You can look at them. After that applications, the SHA-2 hash function is implemented in some widely used security applications and protocols, including TLS, SSL, PGP, and SSH. SHA-512 is a part of system to authenticate archival video from the International Crime Tribunal of the Rwandan genocide. TLS and SSL, Transport Layer Security, and its predecessor, Secure Socket Layer SSL, both of which are frequently referred to as SSL, are cryptographic protocols designed to provide communication security over a computer network. Several versions of the protocols are widely used in applications such as web browsing, email, internet faxing, voice over IP, that is VoIP, and instant messaging. Pretty Good Privacy, PGP. Pretty Good Privacy is a data encryption and decryption computer program that provides cryptographic privacy and authentication for data communication. PGP is often used for singing, encrypting, and decrypting text. Is often used for signing, encrypting, and decrypting text, emails, files, directories, and hold disk partitions to increase the security of email communications. DNSSEC, the Domain Name System Security Extensions, is a suite of Internet Engineering Task Force specifications for securing certain kinds of information provided by the domain name system DNS used on the Internet Protocol IP networks. It is a set of extensions to DNS which provides the DNS clients, that is DNS resolvers, origin authentication of DNS data, authenticated denial of existence, and data integrity, but not availability or confidentiality. SSH, Secure Shell or SSH, is a cryptographic encrypted network protocol to allow remote login and other network services to operate securely over an unsecure network. SSH provides a secure channel over an unsecured network in a client-server architecture, connecting an SSH client application with an SSH server. Features of SHA-512. The algorithm is used to compute a message digest for a message or data file that is provided as input. The message or data file should be considered to be a bit string. The length of message is number of bits in the message. If the number of bits in a message has a multiple of 8 for compactness, we can represent the message in hex. The purpose of message padding is to make the total length of padded message a multiple of 512. Why not SHA-1? SHA-1, a standard hash function developed by NSIT, creates the same 160 bits digest, but the function is attack to launch the function is attacks. To launch a collision attack, the adversary needs to test 2160 by 2, that is 180 tests in collision algorithm. Even if the adversary can perform 230, that is more than 1 billion tests in a second, it takes 250 seconds, more than 10,000 years, to launch an attack. Drawbacks of SHA-2. The SHA function were not quickly adopted despite being better secure than SHA-1. Reasons might include lack of support for SHA-2 on the systems running Windows XP or older, and a lack of perceived urgency since SHA-1 collisions have not yet been found. SHA-512 is secure. The new hash function, that is NIST standard, is SHA-512, which has a 512-bit digest. This function is definitely resistant to collision attacks based on the random oracle model. It needs 2512 by 2, that is 2256 tests to find a collision with a probability of 1 by 2. The comparison of this is a comparison of SHA properties. The message digest size, you can see that for SHA-1 it is 160, for SHA-256 it is 256, thus for SHA-3 84, the message direct size is 384, and for SHA-512 it is the message direct size is 512 bits. The message size should be less than 2 power 64 for SHA-1. It should also be less than 2 power 64 for SHA-256, and for it should be less than 2 power 128 for SHA-384, and it should be less than 2 power 128 for SHA-512. The block size for SHA-1 and SHA-256 is 512, and for the block size for SHA-384 and SHA-512 is 1024. The word size for SHA-1 and SHA-256 is 32, and the word size for SHA-38, 384 and SHA-512 is 64. The number of steps for all of them are same, that is 80 steps. The output, the security for SHA-1 is 80, the SHA-256 is 128, the SHA-384 is 192, and SHA-512 is 256 bits. Thank you.